Hello everyone, in this video I'm going to show a pretty simple example of setting up some sockets between a server and a client. The idea of the server is that it's going to accept multiple connections from multiple clients. In this case we're just going to accept one connection at a time. The client will then send something to the server and then receive a response and be disconnected. We're essentially creating something called like an echo server, where whatever the client sends, it's going to receive a response back that basically contains its own input so that we know that it received exactly what we sent to it. The application protocol is going to be very simple. It's just going to be a single byte that's going to then be followed by an array of bytes. The single byte is going to explain how long the message is going to be. So the strings can only be up to 256 or 255 characters, which is fine. We're not going to send any long strings or anything. And then we'll follow that with the actual string that the user typed in. All right, so let's get started. We'll start with the server example. Okay, so I've set up a project here, a Java project. I'm calling it live server example or socket example because I actually did a socket example already. And I've just got a server example and a client example without anything really in them. Let's begin by importing the necessary libraries. So we need java.net.star. This will give us access to the socket and server socket. We're going to need java.io.star. This will be when we're dealing with input streams and output streams. We'll want that. And then java.nio.charset.star. This gives us access to the charset variables, which is important when we're going from string to byte array and then from byte array back to a string. Okay, so the first thing I want the server to do is it is going to set up a it's going to bind a particular port. So server sockets actually bind ports. This allows it to accept any connection that comes into your computer on that particular port. Note that when you run your server code, at least the first time or the first few times, you might get a warning from something like Windows Defender or something similar. That's just typical when an application is opening up a port and accepting all possible client connections. You know, Windows Defender may ask you, are you sure you want to do this? So you're just going to say yes because we're just running this for a very short period of time. Okay, so we're going to set up a server socket equals server. We're going to start it at null. And we're going to need to do a try catch when we actually initiate the server. So I'm going to say a new server socket, and I'm going to pass it the port 1236. And it's going to automatically give me something that says that it needs to handle IO exception. One thing I like about Eclipse is when you get these type of errors, you can just click down here to surround with try catch, and it basically puts a try catch around it for you. I find this useful because sometimes I'll forget like what exact error do I need to catch, and you know, Eclipse will essentially fill that in for you. Down here, if we do get this error, we're going to just go ahead and exit. Actually, I think it's system.exit. There we go. Just because if we can't bind the server, we can't do anything. So we're just going to go ahead and shut down. That does remind me, I'm going to make a Boolean called shutdown. Because essentially the server is going to run almost forever. So we're going to be stuck in a while loop. And one way we can control that while loop is with a Boolean. And if we receive a certain command from the user, we'll set this to true, which will cause us to exit. Okay, with the server set up, we can now come down here into our actual while loop. So essentially what we're saying here is while we are not shut down, so we're just going to continuously be running. Once the server, let's add a print line here. We'll just say port bound accepting connections. Just something so that we can debug and know that we've actually made it to this point. Now here, once we're within the shutdown, we can actually start to receive connections in. So first I'm going to set up some variables I'm going to use. We're going to make a socket called client. We are going to make a, we're going to need an input stream called input, and an output stream, we'll call it output. And we're just saying these all equal to null. Now here I'm going to need another try catch, but we'll let Eclipse tell me which one it's going to be. Because I'm going to have client is equal to server.accept. The try catch is for IO exception again. This time we can actually continue after the exception. So we can say continue here. Because basically if we fail to get our client, we can't proceed, but we could stay open and try to connect to another client. So if something goes wrong with the client connection here, we're just going to continue on. If another client connects, we'll accept that. Okay, so inside the try catch loop, I have my actual client. Server.accept is going to block, meaning your code will stop running until a client connects. So if you're actually putting in breakpoints, you'll see that your code stops here at line 29. But once the client connects, it'll continue on from here. So moving forward, we can assume that we have received a valid client connection. So what do we want to do once we get the client? Well, let's set up the input and output streams. It's very easy to do. You just call get input stream. That returns the input stream. And I call get output stream to return the output stream. So now I have the ability to basically read and write bytes from the client. So the very first thing we're going to do is following the application protocol that I said. The first byte that we read is going to be an integer, and it's going to say how long the rest of the message is. So I'm going to set integer in is equal to input.read. The simple read call, it says it's of the integer type, but in my experience, it actually is a single byte. So if you actually go over 256, it'll round or it'll roll over. But it does treat it like an integer in what it returns. So we read off this, and this gives us how big the message is. The next thing I'm going to do is set up a byte array called data, and it's of size n. Because this is Java, we can create an array of a variable size, and we're saying we want an array of size n because that's how big the message was told we were told it's going to be. Next, I'm going to call input.read, but this time we're going to choose the option where we send it a byte array. When you do this, it is going to take the byte array, fill it up, and then return from that call. Note that for some of these, like with read all bytes, that actually waits for the client connection to close, and that's not exactly what we want. We could also choose to do read n bytes, with n being the length, or we could just pass it the array. Because the array is the size of the length, it's going to read incorrectly. Again, this is another blocking call, meaning that if the client has not sent this data yet, your code is again going to stop. It's going to wait for that amount of data to be received. But in reality, our client's going to send things almost instantly. The sockets automatically queue things up for us, so we're able to just sort of read off the input stream without having to worry about waiting for it. Okay, so once we have their data, we want to convert it to a string. So I'm going to say client input is equal to a new string, and an actual constructor for the string is to give it a byte array and then define the char set, which is just going to be the standard char set dot UTF underscore 8. If you have, so I may have misspelled something here. This should be from java.nio.charset. Let me try again. Standard charset.utf underscore 8. Misspelling something here. Standard char sets.utf.8. There we go. So yeah, take a look at these errors sometimes and see what Eclipse recommends to you. In this case, I forgot that there was an S here. By the way, if you're ever confused about how to convert between things, like if you have a byte array and you want to turn it into a string because you know it's a string, Google it. If you Google, Java byte array to string, you'll see 100 examples that all say, do something like this. So you just kind of copy that and you'll find that it works. So once we have the client input, we're just going to output it to the screen. Okay, and now we're going to compose our response to the client. The response is just going to say your input was, and then we'll put their string inside of like brackets or something. So this string will be our response, and it'll be equal to your input was, then we'll copy their input in. Okay. One thing that I'm going to want to do is to make sure to take out any new line characters. So to do that, I believe it is just simply replace. We're going to say /n with, you know, a space or something. This is just in case they send us a new line character, which is very possible. I actually don't want to send that back. This really isn't that necessary. It's just to kind of clean up the input a little. Okay, so the string response. Let me just check one more thing, because I think there may be a better way to do this. Will I accept this as a string? Or does it have to be single character? Okay, so yeah, this will work. Yeah, this basically says wherever you see a /n, replace it with nothing. So we want to actually erase the new line character. Okay, so the response is just going to be your input was, and then inside square brackets, what they actually said to us. Now we need to send this back out to the client socket. So the very first thing we want to send is the length of our message. So what we're going to do is we're going to type output.write, and we're actually going to go with this integer option. And we're going to put response.length. So it's just going to send us, it's going to send the string length out first. Then we can actually send the string. But it can't be just the string. It has to be as the byte array. Again, if you were to Google how to go from string to byte array, you will see that there is something called the getBytes function, which just converts a byte array back into a string back into a byte array. So this will send across following our application protocol. First we send the length, then we send the actual message. And now we can actually go ahead and close the socket. The idea here is that the server takes the input, responds, closes you out. This is similar to how like web servers work, where you send a request, get a reply, and then the server closes your connection. And that would actually be it for us. We would loop back around and potentially wait for a new client. What we can also add in here is just something to check with the client input. If they input the string shutdown, I'm using the equals ignore case so that I can compare a string without worrying about if they did a capital S or a lowercase s. Then I'll set shutdown equal to true, and I'll actually output to the screen shutting down. This just gives me a way to shut down my server remotely, which is just very useful for debugging. As I'm running through these tests, it's easy to leave the server up, and just the ability to shut down before I close everything out just makes things a lot easier. Okay, and that's actually it for our server example. It's very simple. We're accepting clients. We're setting up the input and output streams. We read in the input from the client. We compose a response and send it back out. Then we close what the client has to say, and if they actually said shut down, we're going to shut down the server. Okay, let's go over to the client side, because if you run this right now, nothing's really going to happen because it's going to be stuck right here waiting for a client to accept. So before we continue, we're actually going to have to finish up the client example, and then we can go through what the server example looks like. Okay, here in the client example, I'm going to need to import a similar set of, in fact, the exact same. Let's just go ahead and copy it from the server. So we need to import the .net, .io, and .nio.charset. Okay, so what the client's going to do is first let's go ahead and prompt the user to input something. System.out.prints inputs a string. Now we're going to set up a buffered reader that's going to connect to the system.in. And what this does is it allows me to just call readLine to basically read in a string from the user. So we set up a new buffered reader, which is a new input stream reader, which is composed of system.in. System.in is an input stream. We tie to an input stream reader and then to a buffered reader, and then that allows us to just call, very simply, user string is equal to user input dot read line. So now I'm able to just quickly get this read line up. Got to add a try catch. So we'll just go ahead and surround ourselves with that try catch. In fact, we'll just go ahead and continue working in here because we're going to have a lot more try catches that throw the IO exception. So we can just continue on inside of this try catch. And if we ever fail, if we fail to read from the user or we fail to connect, we just want this client to exit. The client doesn't stay active, so it can just exit every time. Okay, so now that we have the user string, we want to set up a socket to the client. That is using the socket class. So in the server, you use the server socket to bind, and then you accept sockets, which is actually a copy of the client socket. Over here, we just use the socket itself. We'll call it connection. And here we need to define what we are connecting to. There are multiple constructors that you can use. The one that we are going to use begins with the IP address. I believe it has a 1 here, and then the port number. Did I get this a little backwards? Oh, yeah, it's just the IP address and the port. Sorry. The 1 was something else for the server socket. So the IP address is 127.0.0.1, which is the local host. That is your own computer. So essentially saying we're not going to go out to the internet, we're just going to go back into our own network card. And the port is 1236. That's the same port that I chose to bind here. I chose the port 1236 because it's not being used on my computer by anything. If it is being used by something, you're going to need to pick a different port number and just make sure it's the same port in both scenarios. It just has to be something not being used. I used to always use 1234, and then I'd find applications are using that. So now I just use 1236. Just 1234 plus 2. Okay, so once we have our connection, if there's an error, we'll come down here to the IO exception. So we can assume now that we have a connection to the server. So the first thing we're going to do is we're going to send the server. Oh, just like before, we're going to need to set up an input stream and an output stream. And an output stream. And then we're going to go ahead and write our string, which is going to look exactly the same as when the server did it. We're just going to output, write our user string dot length. So first we have to tell the server how long the message is going to be. Then we're going to write our user string dot get bytes, which is going to write out the actual byte array of the string. Now we are going to get the response from the server. So first we're going to have to read in from the input how big it is. Then we're going to declare an array of that size. And then we'll call input.read with our array, which will now be filled up with the data. Again, we're going to have to convert it to a string. We pass it the byte array, and we let it know it's of the type standard char sets.utf.8. There's different ways that you can transmit characters. We're just basically saying we're using kind of like the standard ASCII character set when we say utf.8. Basically, it's saying it's an 8-bit character set. Okay, so now that we have our response, let's just output it to the screen. And by now our socket should be closed, but we can check. We can say if connection dot is closed. We want to put a not here. So if it is not closed, then we'll just go ahead and close it. And that really should be it. We now have a client that connects to the server. It sets up its input and output streams. It outputs whatever the user typed in. Then it reads in what the server responds with, turns that into a string, outputs it to the screen, and then closes the connection. The client is not going to stay up and running. The idea is that the client will just have to be run over and over again. So let's go ahead and run this and see what happens. First, if I run the client example by itself, let's input a string. I get a failure. Connection refused to connect. Why is that? Because I'm not running my server. We are relying upon the server to be up and running first. You could potentially elaborate on this connection. You could look for the java.net connection exception, and then you could try to reconnect or put a timer in here so it tries to reconnect later. We're not going to do that. This is meant to be kind of a simpler example. We'll just make sure the server is always running first. So when I run the server, nothing really happens. It says port bound, accepting connections, and that's it. When I come back to the client and I hit play, I can say hello there and hit enter, and it responds with what the server said. Your input was hello there. Now, how do I check on what the server sees? Down here in Eclipse, you'll see something that says display selected consoles down here next to the console window. Click on this arrow and you can actually switch between all of the applications that are running. So we can see that the server is still running, but the client example has been terminated. The client example terminated because it finished what it was there to do. But the server is going to keep running and accepting new clients. So I can come back here to clientexample.java, hit play, and I can say, here is a longer string for you, and get that input. And if I go back to the server, it got a new connection, a new client, and it responded. If I go back to my client, I could run it again. This time I'm going to say shutdown. The server responds, but what happened to the server? It's terminated now too. Because it got the shutdown command, it went into its shutdown mode. Now, what happens if you have the server up and running, and then you accidentally run another server? Well, you're going to get this error. Address already in use, bind. This means that you tried to bind the port, but you failed to because something else had already bound the port. If something else on your computer has bound the port 1236, you're going to get this error right away, which means you may need to choose a new port. But if you're getting it the first time, but then the second time you run, you want to come down here and check if there's not another server running. If you find that a server is running, you just hit the stop sign, and that will terminate both servers. So to run the code, you want to have it actually open on your window. So whichever one of these that you have open is the one that's going to be run. But then when you want to terminate or view the consoles, you have to come down here in Eclipse. So again, we can run the server. We can come over and we can run the client as many times as we want. Right? And every time I run it, it's going to stay with the client. But I can always come over and check the server example to see where it's at. Or I can jump back to client example to finish inputting my string. And when I'm done testing, I'll just say shutdown. And now both of my applications have been shut down. Similarly, if you didn't do a shutdown in your example, or you did not bother with it, it's refusing because there's no connection. So let me get the server up and running. If you just want to just shut down the server manually, or you've hit like an infinite loop, for example, just come over to server example, say terminate. Now you've closed down both of them. But to run it again, you've got to click back over to your server example code and actually hit play. Okay, so this was a very basic example, but you'll find it to be very useful moving forward. If you can send strings between your client and server, you can do a lot of things because you can convert the string into a lot of different data types. As long as we're not sending full objects, you could basically convert the string. In fact, what some systems do is they're using things like JSON or XML. By sending a string back and forth between the client and server, you can even recompose an entire object because the JSON, the way that it's written, can represent an object in object-oriented programming. Same with XML. So you can actually use these languages to send a very long string to your server, and your server can use that to reconstruct an object that you need. But if you're just doing simple things like sending integers or doubles, again, you can send a string and easily convert that string into the integer once you're on the client or server side. Okay, so that concludes this video. I hope that it was informative on how to use sockets. Sockets are a bit of the lowest level. It's kind of where you're writing your own application protocol. But in my personal experience, I've mostly done most of my work with sockets. In my industry, we don't use web-based stuff as much, though we are kind of starting to move to some of that. We tend to just do communication strictly with sockets. All right, so if you have any questions about this, please let me know. I recommend you try this on your own. You follow the code that's here. Pause this video, copy this code, pause the video, copy this part, and then copy this part. Get this actually running on your system. You'll just need to set up a project with 2 different Java files. Both of the Java files actually have a main function because they're essentially going to run as separate independent programs. Once you set them up, just copy this code in, get the client server running, and feel free to change things. If you want to change the response, you want to try different things, feel free to do so. This is just meant to be an example, an in-depth example to give you a good feel about how sockets work. And if you have any questions about them, please feel free to let me know.